Hello everyone, I am Srinidhi Kukula. Welcome to the session 2 of Polymers. The topic we are going to discuss now is ceramics. Under ceramics, these are the contents we are going to discuss in this video session. Introduction to ceramics, traditional ceramics, advanced ceramics, its properties, its manufacturing and production processes, chemical bonds, applications in aerospace and aeronautical industries, then some of the ceramic materials. Ceramics. A ceramic is an inorganic, non-metallic solid made up of either metal or non-metal compounds that have been shaped and then hardened by heating to high temperatures. In general, they are hard, corrosion resistant, and brittle. It comes from Greek word meaning pottery. The clay-based domestic wares, art objects and building products are familiar to all of us, but pottery is just one part of ceramic world. Nowadays, the term ceramic has made more expansive meaning and includes materials like glass, advanced ceramics and some cement systems as well. Traditional ceramics, also known as pottery, is one of the oldest human technologies that we have seen. It has dated to around 18,000 years old. These are usually clay based ceramics. There are different categories and major types of pottery are earthenware, stoneware, porcelain and bone china. Earthenware is used extensively for pottery, tableware, and decorative objects. It is one of the oldest material used in pottery. The clay is fired at relative low temperatures, around 1000 to 1150 degrees Celsius, producing a slightly porous, coarse product. To overcome its porosity, the fired object is covered with finely ground glass powder suspended in water, glazed, and is then fired a second time. Stoneware. Stoneware clay is fired at a very high temperature, about 1200 degrees Celsius, until made glass like vitrified object. Because stoneware is non porous, glaze is applied only for decoration. It is sturdy, chip resistant, and durable material suitable for use in kitchen, for cooking, baking, storing, storing liquids, and as serving dishes. Porcelain is a very hard, translucent white ceramic. The earliest form of porcelain originated in China. Chinese porcelain was a prized commodity with Arabian traders. Because porcelain was associated with China, it is also called as fine china. To make porcelain, small amount of glass, granite, feldspar minerals are grounded up with the fine white kaolin clay. Water is then added to the resulting fine white powder so that it can be kneaded and worked into shape. This is fired in a kiln to between 1200 to 1500 degrees Celsius. Decorative glazes are then applied following by further firing. Bone china is easier to make, harder to chip, and stronger than porcelain. It is made by adding ash from cattle bones to clay, feldspar, minerals, and fine silica sand. Advanced ceramic. Advanced ceramic are not generally clay based. Instead, they are based on the combination of two or any one of the two. That is, first one, typical oxides used and non-oxides. Typical oxides used are alumina and zirconia. Non-oxides are often carbides, borides, nitrides, and silicides. For example, boron carbide, silicon carbide, and molybdenum disilicide. Next, properties of ceramics. Ceramics, the most important general property of ceramics is that they are refractory. They are rough and tumble material that will put up with fair amounts of abuse in the most ordinary and extraordinary situations. Some of the properties that ceramics have is high melting point, so they are quite heat resistant, great hardness and strength, considerable durability, they are long lasting and hard wearing, low electrical and thermal conductivity, they are good insulators, chemical inertness, they are unreactive with other chemicals. So, how do you make these ceramics? The manufacturing process of ceramics generally start with digging the raw material. So it starts with clay based material dug from ground. Then mixture of this clay based material with water and other material so that the granules of clay are bonded together. Next, this water and other material mixed clay based material is squashed into a shape, or it is molded into the shape whatever the product is required. After that, it is fired at a very high temperature. The US Geological Survey listed six different types of clay usually mined in United States. That is common clay, kaolin, bentonite, ball clay, fuller's earth, and fire clay. So each one of these also has numerous different grades and qualities. So it's probably more accurate to talk about china clays or ball clays. So these ball clays is used to make things like fine porcelain, tableware, bathroom suits, but even within a single ball clay mine, different grades of clay will be simultaneously excavated from different areas and kept separate for different end uses. Chemical bonds of ceramics. Underlying many properties found in ceramics are the strong primary bonds that holds the atom together and form the ceramic material. So ceramic, these chemical bonds are of two types. They are either ionic in character or covalent in character. Ionic in character involves a transfer of bonding electrons from cations to anions, or either they are covalent in character, involves orbital sharing of electrons between the constituent atoms or ions. Covalent bonds are highly directional in nature, often dictating the types of crystal structure possible. Ionic bonds, on the other hand, are entirely non-directional. So this non-directional nature allows for hard spear packing arrangements of the ions into a variety of crystal structure. So this comes with a package of two different limitations. The first limitation involves the relative size of anions and the cations. Anions are usually larger and close packed, as in the face centered cubic or hexagonal close packed crystal structure found in metals. The second limitation on the type of crystal structure that can be adopted by ionically bonded atoms is based on the law of physics that the crystal structure must remain electrically neutral. This law of electroneutrality results in the formation of very specific stoichiometric, that is, specific ratios of cations to anions that maintain a net balance between positive and negative charges. The types of bond, that is, either most of the primary chemical bonds found in ceramic materials are actually a mixture of ionic and covalent types. Secondary bonds are also important in certain ceramics. For example, in diamond, a single crystal form of carbon, all bonds are primary, but in graphite, a polycrystalline form of carbon, there are primary bonds within sheets of crystal grains and secondary bonds within the sheets. Next, the use of ceramic materials in aerospace. Ceramic materials used alone or as part of an overall material system have several attributes of great benefit in many aerospace applications. In simple terms, they offer high temperature capability than metals. They are exploitable through both increased combustion temperature and reduced component cooling requirements in gas turbines and in high velocity aerodynamic control surfaces in missiles and aircrafts. They offer lower densities than metals, offering lower so which results in offering lower weight components, thus improving the system payload or range capabilities. This offers greater flexibility in changing the center of gravity of structures to more appropriate locations. Ceramics offer higher stiffness and hardness than metals. So this gives improved wear capabilities for bearings and seals. Ceramics also offers some application specific properties like radar, infrared rays, or other electromagnetic wavelength transparency. Ceramics also has application in air jet engines. For example, they are used in gas turbines, which work by burning fuel mixtures at very high temperatures to make fiery exhaust that powers a plane through the air. Ceramics are used as ceramic tiles in the outer skin of space shuttle to protect it from burning up on its way back to Earth from space. So now the next generation space shuttles planes is expected to use high performance tiles made from ceramic matrix composite, which is already been used in Falcon from SpaceX. Ceramics are used in even in a modern age of plentiful plastic, bricks, glass, cement, concrete, porcelain, and tiles of all kinds are still the raw materials for which most buildings are made. The tools used in construction sites are often made with ceramics too, whether you are cutting glasses, drilling holes in tiles, grinding concretes, or sawing through bricks. Engineering ceramics like tungsten or silicon carbide will help you knock more traditional ceramics into shape, generally working better for longer than traditional tools made of steel. Ceramics, they are used in power plant generator and transformers. They are also used, high performance ceramics are also used to make high temperature superconductors. The most advanced electrical use of ceramics is probably this type of superconductors with materials with virtually no electrical resistance. While traditional superconductors have to be cooled down to near absolute zero temperature, these new ceramics become superconducting in relatively warmer conditions up to minus 180 degrees Celsius, which makes them far more practical for use in things like maglev trains and cutting edge computers. These are some of the ceramic materials which is used in daily life in aeronautical and also in aerospace industry. Ceramics, alumina, one of the most popularly used, aluminum nitride, boron nitride, corderite, corning pyrex, graphite, lava, macor, quartz, sapphire, silicon, silicon carbide, silicon nitride, steatite, tool steel, zirconia. So these are some of the ceramic materials. So this is the second session of polymers, that is ceramics. So here we have discussed about what is ceramics, what are the different types of ceramics, the modern materials of ceramics. Then we have discussed about some of the properties of ceramics and its comparative study with metals and metal alloys. Then we have studied how to make ceramics and different types of clays. Then we have discussed about the chemical bonds in ceramics, primary bond, secondary bond, etc. Then we have studied about the aerospace application of these ceramic materials. And then we have known some of the ceramic materials which is usually used in daily life and in aerospace industries. If you have any doubt, clarification, suggestion, please comment below. Thank you.